Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. We want to give a big thank you to Greg Kozak, one of the viewers. We did a video on the importance of coolant and keeping it clean, and Greg made a comment that they use these filter socks that he uses to keep his filter clean. And so he gave me a part number. I started looking up, see what these things were, checked with my source, and ordered 225 microns, a 10 micron and a 5. And right now we're going to start with the 25 micron and see what happens. Now, I'm not a plumber by trade. When I went down to the hardware store to get some of the stuff I needed for this, the checkout guy asked me, says, "Are you a plumber?" I said, "No." And I said, "That means I'm going to be here 3 more times before I get this project done." It never fails. I never get the stuff right to begin with. I'm kind of a bonehead when it comes over to plumbing. So we're going to work on this unit. It's not done yet. We're just going to use it for now. Just we'll work some of the kinks out, but I just want to show you what we've done. We've taken and made this unit right here. It has some slots down in the bottom that feeds down in the coolant tank. This filter sock, we cut the hard plastic off over here. It fits down inside there, and it's hose clamped around a 2-inch piece. Now, one of the things that I didn't mention as far as one of the variables you want to control in your grinder, a lot of times I'll see people with this setup, they'll have a very stiff hole that's a hose that's going down into their tank, and it's extremely stiff. And as you move your y-axis in and out, this has got to move. And if there's any resistance there, it can affect the accuracy of your table. So we got a little flex right in the middle. I got this tube, there's a 1.5-inch tube that can slide up and down. This whole thing can flex back and forth as the table goes. And there, with that, I have very little pressure put on that y-axis. You can see that we're leaking a little bit. We tried some things, and so we made some adjustments. And we might leak a little bit while we do this video, but that's fine. We'll take care of that later on. So what we're going to do today, Brian, another viewer, he wanted to know some tips on grinding cold, or actually soft steel, and getting a nice surface finish on that. And so I told him that we plan on doing a video. We'll see what we can do. I'm just letting you know up front that most of my grinding is with hard steel. Probably 95% of what I grind is hard. I have ground soft steel, and I really don't use any different technique. I might change my wheels a little bit. The technique I use for grinding soft steel is the same that I use for grinding hard steel. And basically, if I got 10-15 thousandths, I'll rough the block down till I got 1 thousandths left. I'll redress my wheel, and then I'll come and do my cleanup if I want to get a really good finish. I'm going to take a guess that this wheel that actually came with the surface grinder, based on what I've seen it have done on OD work, I'm taking a guess this is going to give me my best finish. It's a 46 grit. It's an H, and it's kind of a medium as far as the porousness on there. It's I don't know if you can get a close-up on that or not, Adam. And you can compare it with this wheel. This is another wheel that's 46, and I believe it was an H. Yeah, this is a Ruby. It's a 46. It's H. And you can see the difference in how open this structure is compared to this. This will have a little more cutting edges. You can see both wheels are loaded up, and that's what happens when you cut and soft steel. The steel particles are soft, and they wrap around the individual grit. And when they wrap around that grit, they get caught in there. And when they get caught in there, you end up eventually, as you're grinding across there and it loads up, you got steel rubbing on steel, and it really affects your finish. So that's why I'll rough a lot of the stock down, not worry about the finish, leave 1 thousandths on there, and come and clean it up, because if I leave just 1 thousandths, the chances of me loading that wheel up to where it's going to mess up my finish real bad is slight. So what we're going to do something similar to what we've done in the past when we were grinding some hard steel to find out some surface finishes. This time we're going to do soft steel. We're going to start with this wheel, and I'll grind this block. And what I'll do is I'll grind the whole block with this first, get a finish, and we'll leave this finish on half of the block, and then we'll start grinding the other half of the block using these other wheels. I think the wheel that will probably have a possibility of doing as well, if not better than this, will be this aluminum oxide, this 46.2 grit. I've used that in the past with a lot of soft work. It's a J hardness. It's a little bit harder. I know the websites, they recommend that you go to a harder bonding material when you're grinding soft steel, and I think that might be right up to a point. If you start getting into your really hard bonding material, the wheel's not going to break down. At least when these load up and they rub, a lot of times they'll break down a little bit and expose new grit. So with a hard bonding, the grit's not going to peel away on you, and so you're going to end up, I think, rubbing. This wheel right here, the one that I showed earlier, which is porous, this thing is really hard to load up. You can see all the different pockets that are in here. It allows a lot of coolant to get in there to keep the stuff washed out. It keeps the part cool, and you'll be amazed if you get one of these open structure wheels like that. You'll be amazed at how much stock you can take off before that wheel starts loading up. Another wheel that we'll try, this is a 46 grit, it's H. This is aluminum oxide ceramic mix. It has an open structure on it. This wheel actually works really nice on hard steel. I don't think I'm going to get the finish that I'm going to really like in soft steel, but we'll give it a try. This wheel, this is a 60 grit, and it's a K hardness. And it also is a ceramic aluminum oxide mix, but you can see over here it's a very closed structure. So we're going to end up with a lot more cutting edges, but we're going to not have a whole lot of room for loading and for the coolant to come in and cool. So I'm going to set the wheel up. We're going to start out with this wheel, which I think is going to probably give the best finish. We're going to set up, get the wheel dress. I'm going to go ahead and clean the block up. We'll flip it over, and then we'll start working on this side, and then we'll come back and we'll look at that finish, change the wheels out off camera so this video won't go for hours. We'll take some more cuts and we'll see what happens. So we'll be back in just a bit. This is the first test that we've done, and this is using that 46H wheel that came with the machine, the wheel that I think we're going to get the best finish on. And as you can see, it is a very nice finish. Zoom up on this a little bit. Now this line right here, that's just where the co-roll hasn't cleaned up. But as I zoom up on this, you can see these lines going through here. That's not from the grind. That's when I use my Brown & Sharp indicator, which has a 80 thousandths diameter tip on it. It's carbide. I have 8 thousandths travel in that indicator, and I sprung this so that it was about halfway, so we had about 4 thousandths worth of spring tension on the tip, and that's just sliding across there. Those lines were left underneath the carbide ball, and that's one reason why I hate grinding and working with soft steel, because even if you can get a real good finish, to keep a finish real good on there, it's kind of hard. Those little lines, again, that's from the ball of my indicator rubbing across it. Now, you can't really see it in this picture right here, but there's some streaks that you can see with the naked eye that it's hard to see with the camera. And I think that is possibly from some of the loose grit that's in the wheel. What I'm going to do is I'm going to use that same wheel right now. I'm going to redress it, and I'm going to take a popsicle stick and I'm going to clean the grit out of that. Adam will film that so you can see what I'm doing. And then I'm going to take another cut on this, and I'm going to see if it will take out those streaks, which I believe is from the loose grit. And if anybody has ground electrodes, carbon electrodes, you will see that if you don't clean the loose grit from your wheel, it'll leave a real bad finish. You get that loose grit cleaned up and you wouldn't believe the difference it'll make. So we're going to try it with this piece of co-roll, especially seeing the fact that just dragging my indicator tip caused those lines in there. When you're dressing your wheel, a lot of your finish will depend on how fast or how slow that you come across here. I don't have enough experience grinding the soft material to really know. I know in the hard material I got my speeds just right where it works out good, and it may be a little bit different grinding soft. I took about 1,000 on my last pass. Came across at the speeds I normally would do for a hard steel. What I do now is just take a popsicle stick, and basically all I'm doing is going in there and trying to knock out all the loose grit. I'm just touching right now. I'll set my digital to 0, and I'm going to mimic how I would finish this up. And basically what I'm going to do is I'm going to drop down about 6/10, come across. I'm going to come back across over the other side. I'm going to drop down 2/10, and then I'm going to come back and I'm going to try to drop between 1 and 2/10 for my last cut. Okay, what you're seeing on the screen now, we use the same wheel, but we used the popsicle stick to knock the loose grit out. Adam stood the block up this time like that rather than at an angle, so his depth of field would remain the same, so you can get a picture of a better view of the entire surface rather than the focal point at one point. And again, what you see right here, that's just where it's not cleaning up yet. You can see again with the indicator tip, this material so soft that you can actually see that in the finish. It's pretty close to the same to the naked eye. I don't have a roughness surface checker that I can really check on this, but to the naked eye it looks pretty much the same, except in this case you don't have the streaks that you could see before that the loose grit was causing. So the next test that we'll do, we'll use that 46H with that very open structure, and we'll see what happens with that. Okay. Now this cut, we used the 46 grit ruby wheel, and what we did, the difference between the two, they're both 46H. This side right here is the original wheel we started with, and it's got a closed structure. It's not near as porous. This one here is a very open structure. And so, as you can see, we definitely got a better finish over here than what we have on this one. This surprises me. I figured that with that closed structure we would be getting a lot better finish. But and keep in mind, when I'm cutting on here, I'm touching off, and then I'm feeding down 6/10. I'm coming across up halfway, backing up, coming down 2/10, coming across, back up, come down 1/10, and then back out and feed. And that's what I've been doing. I'm trying to keep everything consistent from one cut to the other. But the finishes are so close, and when you look at the naked eye, they're so close. Some of this could be just from the dress of the wheel. Depending on where I'm using the cluster diamond, I may be on a better part of that cluster on this than that. The finishes are close. What I'm going to do now, though, I'm going to stick the aluminum oxide wheel up, the 46.2 grit. That's the one I think that's going to give a nice finish. And I'm going to start on this side from our original, because we got a better finish. I'm going to start on this side, and I'm going to cut to the halfway mark. And again, you can see the indicator lines from my indicator. This line right here just steals some of the original finish that we had, or I shouldn't say the original, it's a co-roll finish. So it's not what the wheel is put in. So I'm going to grind now our very first part over, because we have a better finish with the open structure than we do the closed structure. And now we're going to go with a different hardness. At 46.2 wheels, a J hardness, these are H. And based on the information you read on the internet, the hardness of the wheel, if it's harder, it should work better. So we'll test that one out on the next cut. I'm going to go back just for a minute to the last test we did. This was the 46H with the open structure. This was the 46H with the closed structure. One thing I forgot to mention is, if you look right in this area, this is the blend line where I'm coming about halfway in, backing out, coming back in again. I'd go down about 6/10, come in, stop right there, back out, go down 2/10, come in, back out, take off 1/10, and come over to that point and back up. And as you can see, the cutting edge of the wheel, it starts here, and as it cuts across, that's part of the wheel is what's taking all the abuse. You can see it in this little section right there. What's happening there is the grit is breaking away and breaking up, and it's leaving a little rougher finish in there. Over here, you got the fresh dress in this area where the grit has not been attacked as much as it is there. So that's one reason why it's important when you're grinding something and you can come all the way across. You always want to come all the way across and back up. Now on something like this, if you were going to grind something and that had to stay good in this section, you would position your wheel at that point, and that's where you'd just slowly drop down, and then you'd come across this way. You'd come back, drop down, and come that way. And then you can eliminate that. But for this test, we're not doing that, and so I just wanted to show that. Well, here's their next part. And this is with the 46.2J, and this is with that 46H that was open structure. It's hard to tell. I did come quite a bit further over. It's hard to tell, but it looks like the 46.2J, if you look at it with a naked eye, it might be just a little tiny bit better. I'm trying to keep all the variables the same as I can. One of the variables that I'm not controlling, when I'm changing the wheels, I'm not balancing them. It will take a lot of time. But some of this could be in the differences in their finishes, that maybe one wheel maybe even a little bit more balanced than the other. You would really have to throw these wheels up here probably about a half dozen times and do your test and look at your results and stuff like that and see if they stay consistent. Actually, if you wanted to take the time and balance the wheel. But these finishes are so close that there's not that terrible much difference. And again, it could even be in the dress of the wheel. The next test we'll do, and I'm going to go ahead and leave the 46.2 on. We're going to grind this side now. And what I'm going to do is I'm going to take, with the aluminum oxide ceramic mix, I'm going to take that wheel, and it is a 46H, and then we'll grind and we'll see what we have with that combination. Okay, this test we cut on this side with the 46H ceramic aluminum oxide mix, and this was our 46.2J. If you look up over here, you can see, I believe this 46.2J has got the better finish on it. When you look at it with the naked eye, you can see it even clearer. You can see the different lines. And it doesn't surprise me, because this particular wheel, the 46H ceramic with aluminum oxide mix, was actually designed for cutting hard steel and taking a lot of stock, being aggressive. It's a really good wheel for taking a lot of stock aggressively off hardened steel. So it still looks like the 46.2J's got our better finish. The next wheel we're going to try is going to be 60K. The differences we're going to have there, we're going to have a finer grit. We're also going to have the K hardness, which is going to be, I think, the hardest wheel that we will be trying. And we'll see if that'll make a difference. Again, it's a ceramic aluminum oxide mix, so I'm not sure what the outcome of that one will be, but we'll learn together. Okay, this test, we had on the left side, we had the 60K ceramic aluminum oxide, and on the right we had the 46.2J. And if you look over here, that 60K did a pretty nice job. If you look at it with the naked eye, it's harder to see in the picture, but if you just look at it with the naked eye, the finish does look better on the 46.2. If you get it and hold it and get the light reflected from it just right, we might not be capturing that in some of these images. But the one thing I want to point out is when we had a K wheel, look how clean my line is. I ground the same way, took the thousandths off, stopped with my digital at 0. Look how clean that line is. So with the K, we didn't get any breakdown on that cutting edge. But the one thing you can see with the naked eye, from here to here, you can see it is a shinier finish on there. And it actually looked like it's got a better finish being just a little bit loaded up. I've got a little more rub on there, so probably polishing a little bit. And the finish on there, even though they're pretty darn close, with the naked eye, the 46.2 looks good, but right in this area, the 60K looks really nice. I think that might have a lot more to do with the K wheel. So I think the harder the wheel, what would be nice, I don't have any, but to try in just an aluminum oxide, straight aluminum oxide, or ruby, try a 46K and a 40 or a 60K. Those would be two comparisons that would be good too. So there's the variables I can't control in here. Some of the things is the wheel sizes. Some of the wheels were smaller, some were bigger. The balance, different things like that. One thing I want to try, one last thing, is I want to try a little trick we used on grinding aluminum. When grinding aluminum, it's extremely soft, loads up your wheel really fast. And what we would do is we would take straight coolant, and we wouldn't turn the coolant on, but we just take a little brush and we would paint the part and hit the wheel with just straight coolant. The straight coolant is really slippery, and let's see what happens here. Let's see if it will give us. I'll put the 46.2 grit wheel on there again. So I'm going to grind this side and compare it to our original 46.2 running coolant, and this one will be straight coolant painted on. Okay, I just poured some straight coolant. Come up here and I'm just going to paint the part. Get that on there, dabbed on there nice and thick. I'm actually going to hit the wheel a little bit with it. I don't want it to grab there. my last cut, I'm taking a very slow traverse in the Y. I'm keeping my speed as consistent as I can. I've been, all the test results, I've been trying to duplicate the same thing. You can turn the coolant on just to wash the concentrate off. Well, this was the last test. On the left side right here, we ran the 46.2 J wheel. We ran that, that's the side that we painted the coolant on. We had the exact same wheel when we ran the coolant. So you have straight coolant, you have the watered down coolant. And with the naked eye, you can see a big difference. Over here, you can even see, if you look in there, we'll zoom up on there, you can see a lot of difference that it made running that straight coolant over the watered down. I asked Adam to take another view, angled view, to get the light a little bit different. And so again, you got the straight coolant on this side, and you got the coolant mixed with water on that side. And I'm going to try to find the focal point. But look right in here. Look, you can see the roughness in here, and you can see how much smoother. So you can actually see it in this area really well. And again, if you look at the naked eye and you're reflecting the light in it, you can see a big difference. So, and also we got a lot cleaner midsection line than we had. But it looks like if you want a super good finish, use that coolant straight on your softer materials. And I don't know if this has helped you any or not, Brian, but this is kind of the finishes I get. Typically, because I'm grinding with the coolant with water, I guess now if I want to get something that's really nice, I'll definitely do it with painting the coolant on like I just done here. I hope that has helped. And I don't know what kind of finishes you're getting on your projects. There's a couple other things that to keep in mind. You'll see this quite often on the YouTube video. People will have their wheel dressed, and because they're wanting to do the video, they'll turn the wheel off after they dress it. They have the part set up, and they talk, and then they'll turn their wheel on. Well, what happens, you have these little paper, I forgot what they call them, but the little paper shims, these ones are glued. You have those on there, and they don't want you to really reef down on a wheel. You want it tight so it doesn't move, but you don't want to reef on it. Now, if you have a grinder where it just starts full blast rather than a slow start, a lot of times what will happen if you dress your wheel and then you turn it on, you're going to lose the accuracy. If that hole's a little bit sloppy that the wheel mounts on, that will move. And I've seen it before where I just finished dressing the wheel, and for whatever reason, I'd turn the wheel off and I'd come back later and I'd be a little bit lazy, and I thought, I'm just going to turn the wheel on and see where I'm at. And I'll have a chattery finish where before it was really good. Another thing to keep in mind, because the paper, it will compress. If you're grinding throughout the day, stop and tighten this up. I can't count how many times when I would tighten this wheel like I did now, and it should be good. But if I come out here tomorrow and start grinding with this wheel, I might be okay. But it's a good policy to tighten that wheel up. You'll be amazed at how loose it will get overnight just because of that paper compressing. So if your wheel's moving on you, nothing you're going to do, there's nothing you'll be able to do to get a really good finish. And I tried to keep as many of the variables the same as I could. Again, we just done one test with each wheel. We should have done multiples. I didn't balance the wheel between tests. I basically don't balance a wheel unless it's a CBN or a diamond, because the way I use this grinder, these wheels are coming off and on quite often, and if I balance the wheel out every time that I was going to change a wheel, I'd spend all day balancing the wheels and getting very little done. And most of the finishes that I need is more than adequate. And as you can see in the results that we got over here, we didn't balance the wheel for any of these, and a lot of these finishes are really good. And so again, I hope that helps. If not, give me some comments, some other things you might want to see. And again, I want to thank Greg, again, that coolant. It worked great. We did quite a bit of grinding today, and none of the filth came on the table like it normally would do. And that's with a lot of the wheel dressing and everything taking place. And so my first test with the filtered coolant system that I got on here, I love it already. And the nice thing about these socks is when they start getting plugged up, you can take them out and you can clean them out and throw them back in. But they're so cheap, you can just buy a bunch of them, have them on the shelf, and so then you can just dry them out and throw them away. Or if you really want to, just take and wash them out and get them clean and throw them back in there. Well, anyways, that's going to be it for today. I hope everybody enjoyed this video. Give us a like, give us a subscribe. I just want to give a heads up. You want to keep and watch for the next couple weeks, because if things work out right, I got to make a couple parts yet, and we're going to turn this surface grinder into an internal diameter grinder. We're going to do ID grinding, some very high precision ID grinding off this surface grinder. And if things work out right, that'll be next week. If not, I think it'll be the following week, so stay tuned. Well, that's it. Thanks for watching. We'll see you next time.